Ted, you're muted.
This is Ted Selker. Hi, it's BayCHI. This is the April BayCHI program that I'm getting ready to start. And I'm happy to be here as the sun goes down on a beautiful day. We have a real treat tonight. We have Yi-Luen Do from University of Colorado, Boulder. She's been at so many places where she's been creative and inspiring to so many students and even faculty. Ellen and I have known each other for a while. I remember going to visit her and Mark Gross in University of Washington a long time ago when she was working at in the computer science. Well, actually, she wasn't. She was in the architecture department. I'll say a little bit more about her in a few minutes. But anyway, what I want to make sure is that you guys also know that if you wanted to, you could have been hanging out with Ellen for the last hour or so, because we have a dinner. Although it is Zoom, we actually get together and have discussions about any old dang thing from 5:30 to 7. And that happens on program nights, which are always the second Tuesday of the month. And the talks, as you noticed by being here, start at 7:30. Anyway, BayCHI is part of the Association for Computing Machinery, and we are the Bay Area Computer Human Interface Special Interest Group from SIGCHI. SIGCHI has like 7,500 members. ACM has 75,000, and we traditionally have been the biggest local CHI. There's many others, by the way. And I would love it if you guys decided to join. You can go to the website, which you probably found, and join. And what that gets you is, well, you help pay for these things, but also there's a newsletter. And I really like to talk people into being part of Birds of a Feather. So, for example, Edwin Lee runs Birds of a Feather that meets about careers in CHI. And if any of you are interested, I would like to start a new Birds of a Feather about tools of computer human interface. I'll do it if somebody helps me. Whoever keeps muting me, please don't do that. It's very disconcerting. So in any case, this is the time of year when we vote on people for being the treasurer, the chair, and the vice chair. I'm the chair. Edwin Lee is the vice chair. And in June, will there be elections to replace us, we hope. If not, we probably would be happy to help. There are lots of other things you can do, like helping with the Birds of a Feather, or being just coming to the steering meeting, which is the second Thursday of the month at 7:30, is something you can do to get to know us more. And you can see that there's a social media chair that somebody wants to put things up on Facebook and Twitter and all that. They can start working with Nancy Fishberg. Steve Williams, who's always helping a lot. He'd love to have some help making the whole web platform, better. It's some of it's a little bit aged, and so on. We have a consultants list. You can go and put your name up, and people can find out that what you do as a consultant, and so on. There I am, unmuted again. Okay, so consider working for these 3 positions, and with that, I want to get back to Ellen. Ellen is a creative. She loves creating, and more than anything else, she's a connector. She loves making people happy around her and being happy herself. I have known her to be that way for, I don't know, maybe I've known you for dozens of years. and now she's in a group of other people, a program called Atlas at University of Colorado Boulder, where they're all into making and teaching about making and human computer interaction and design methods. And you know, they have a great program there. If any of you guys want to be part of a master's program, they probably would have you come and be there with them too. But they also have a forum every twice a year where you can go and see all of the great stuff they are making, weird buttons and switches and things that fly and things that run around and interact in really strange ways. That's kind of the fun of it, is making things that haven't been made before and writing about those. And so without any further ado, I really want to turn this over to Ellen and have you tell us all about the work you're doing now.
Thank you. Thank you, Ted, for the nice introduction. Okay, so I'm going to try to share my screen. Let me do that. Okay, share. All right, I can start playing. People can see me, right? And are you being blocked? Is that you can see the whole window? Is it being blocked?
You can see the window. Oh, but there's a little window, right? Pattern on it.
Yeah, same.
Yeah, so I think that's part of the
Zoom.
The Zoom thing. How do I even get rid of that? Okay, let me try it again. How do I do high video panel? Does it work now better?
Well,
it's still being blocked. Still have the pattern.
Yeah, maybe a view wants to only be about. There
so
you
if
go.
But it's still being blocked, right?
Oh.
I don't get it. Oh, it's okay now? Is the bottom page being blocked?
The bottom of the little, there's a funny little pattern at the bottom. There it goes away. It's great.
So if I change, how do I do that?
And you can just view. Can you view your full screen?
Sorry. So this guy, where does it go? Floating high meeting control. Hey, I got it. I think everything's there, right?
Yay.
Perfect. Okay. So I'm going to talk about fun with creative technology and design. So right now I'm flying blind because I cannot see the panel chart because I just hide it all away. Okay. So for the next, I guess, 45 minutes to an hour, I will share with you like what I've been doing. So I am in the Atlas Institute, and some people may know me, just about me, early days, decades ago, I worked on sketching. This is the idea about design sketches and sketch design tools, because I was trained as an architect and I was interested in having computer as a tool help architect design. And the project I worked on was called the electronic cocktail napkin. And so the idea is that, hey, if we are in a cocktail party, I can tell you how to get to my house, sketches it, or I have a great idea, just draw that. We can do that with a piece of napkin. What if the computer is also kind of like a piece of napkin that you can draw, annotate, do stuff? Then I realized that I was doing both design computing, trying to make the software computer to do interesting stuff, but also design cognition, because I want to understand how designers think, being trained as a designer. So the design computing part is supporting design activity, and the design cognition part is understanding design activity. And I took the cognitive science because I wanted to collaborate, figure out both building a tool and why we're building a tool, whether it make any sense. Okay, so part of that is also analyzing design activities. And I have done different protocol analysis. So this is an architect video tape when he was doing design, and I was transcribing when he's drawing the architect's office. He's telling me, oh, this is north, and this is the way facing this way, that way. Meanwhile, I transcribe that because the idea is that if I can recognize what a person is doing, then computers should understand what a person's doing. And here's another example. This one is fascinating because the person doing designing is actually doing the reasoning along the way. So here is a floor plan, and then he was asked to put down, oh, maybe let's put down 800 square feet. So you can see 800 is written down there, but 800 also on the side. And then 25 is the width. Okay, 4 times 25 is 100, 4 times 8. 4 times 8 is 32, so write down 32. So the process of that is like, oh, okay, the rest we can divide it 10, 10, 10, 10. So the whole process, the person, the architect was reasoning and drawing and sketching. And to me, that was fascinating because the question I was asking is, what's in a diagram that a computer should understand, right? So if I can recognize different symbol that you draw, the computer should. So the early days, this was some diagram I collected from 60 architects. So we give them design concept and ask them to draw, give them drawing, ask them to write down, and then we do intercoder coding to figure out, do we agree? So you can see when we ask people about lighting, people draw the sun, the light rays coming in, and we talk about rooms, you see people drawing figures, right? So then you have combinations of different shape and for architecture. So their design intention in the symbol. So part of that, I was working on computing sketching sketch design tool. Building tool is interesting because you want to understand how people draw. And so electronic cocktail napkin, so this is more than 2 decades ago, you can put down a 3x3 grid, recognizing what you draw. Okay, it's a line, a circle. Then you can combine things together. Like, okay, here's a circle, here's a cross. That's a symbol for female. Bathroom or triangle on top of box is a house. So you can continue teaching the computer. This is a symbol, this is a language. And my work was called the right to at the right time, sketching as an interface knowledge-based system. So as I draw in the middle here, you can see, oh, I'm thinking about relationship between different lobby. Then I use that to retrieve a case-based library. I draw isometric view, turn that into 3D object. And so I was just telling Edwin that when I was thinking about, I did not realize there's a field called human-computer interaction. I said, oh, there's this line between people and computer. And so sketching is like part of the line, right? So if I draw the floor plan, I want to look at where people are. So this pink thing is showing the view where you move around. Or I want to find a slide, go to the slide library. I don't remember the name of the building. So I draw the sketch. Okay, here's a roof, here's a column, and then I retrieve the Parthenons. So that could be slides, could be video. And so the idea is that drawing could be an interface to different knowledge-based system. So that was where I started with 2D drawing. And then the next tool is called VR, virtual reality sketchpad. And that was because I was teaching beginning architecture student. They draw a floor plan, they happily arrange different stuff. And then I was frustrated because I think they draw the floor plan and looking like God's view, looking at things. I said, why don't you move your floor plan to your nose and lift it on the wall and walk around, see does it make any sense? Then I realized I can build this. So people can draw symbol, you can turn that into a virtual reality. You can, this is the symbol for the dining table, for the TV, for the couch, and then you can have your living room, right? Or you can sketch a shape, you can do a curve roof, you can do massing study. And once you got the virtual reality, you can go inside, then we realize that we also want to sketch in 3D as well. So this project is sketch in the space, in virtual reality. So let's say we need more space here, we need another door, or the window is the wrong place. Can I annotate in 3D place? So I realized that I started from 2D sketching and then moved on to 3D sketching. And from there, I realized that I was doing sketching in 2D, 3D, and now we come to 4D. And so what do I mean by 4D? 4D is like sketching with object. There's time, there's physical object. And talking about tangible, embedded, and embodied interaction. So here are a couple of projects. So on the left-hand side, this is the tile, plan tile. And so there's a screen in front. And as you move forward, backwards, you're actually zooming in and out the map macro or micro view into the plant. And on the right-hand side, this is like a chair we built for physical computing. The idea is that what if I rocking my chair and I'm controlling what I see of the virtual reality or the projection in front of me. So these are like, those are sketches, like you're trying to figure out what interaction might be. So one of the very early tangible interaction project was actually navigational block. So Ken was showing me his computer screen. He built this multimedia virtual reality with lots of objects, and each object is embedded with different music, sound. And then when he trying to show it to me, he ended up click, 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 trying to move, navigate through. I got so frustrated. I said, take it out from the screen, just show it to me. So we started building this navigational block. So who, what, when, where. So as you can see inside, then we can tilt it and then we can do a query, right? So we were working, so this was in Seattle, Pioneer Square. So we can look around, oh, who, the founding father or the miner, or what is the event, the gold rush or the fire, when, 1850 or 1912, or where, what the location. So as you combine that, people will be able to come in. What happened to Lisa? Come back in again. Somebody please admit. Okay. Should I be asking questions? Answering questions? Can I continue? Good. Okay. Yes.
Continue, please.
Good. All right. So here's another project. So this is like a tangible object, and the idea is called Posy. So you have Hop and Struck, the toy, 3D printed, and we can sense which way you're doing. So you can use it as a way to do model. Something just happened. Okay. So you can have molecule object, or you could be making this map to maybe dinosaur, giving different textures and skin, and you can be playing that together. So this to me is so 3D sketching. In a way, I'm talking about thinking with your hands. And so this is a first about what I've been doing and also like where I have been doing. And I think thinking with your hand is about design. And what do I mean by design? We talk about a lot of things, right? We talk about art, science, engineering, and design. And how are they different? Now how they're similar. In a way, art, and what about design thinking, right? So art is about reflecting, and science is about understanding and explaining. And when you talk about engineering, you talk about solving problems. And design is a combination of all of that, but it's also about inventing and making. So all the work that I've been doing is about inventing and making. And I think Ted is also doing a lot of inventing and making. So I think he totally understand or agree. And this is another thing that I share with people. Like if you look at the words and vocabulary, program and design is actually similar meaning. Pro is moving forward, gram is writing, what D is out, science mark. So you look at the origin of the word, both program and design is making explicit representation. So it's like, if you're a good designer, you're good programming, good designer. And so in a way, we all designing our world, all designing our environment. And that's fascinating. Okay. So now it's a segue to creative technology and design. And there's a reason why I put all of them there. Creative, technology, and design. I think we all working in the area, whether it's computer, software, hardware, and also it's a good reason, my excuse to talk about things happen in my lab. So my lab is called ACME Creative Machine Environment. So ACME, the A stands for ACME, is recursive. We like the idea, like in Looney Tunes, right? So you have this ACME company that makes everything. So of course that's funny. We like to be a community that makes everything. So in my lab, we work on multiple things. So can you, are you having a funny pattern? You seeing the pattern?
Yeah, but I think we're seeing everything anyway.
Good. Okay, you're seeing everything. Good. Right. So this is just a quick slash of all the different projects. So where's my mouse? Okay. So one thing in common is that we build things. We build physical and computational artifacts. We build objects to think with. There's a way of working. We work on methods and tools to make things. And like Tess said, we do have undergraduate, master, and PhD program in creative technology. That's our degree name. So Atos Institute is interesting because we do both research and practice. We have professional degree program, and we work on building things. Okay, so object to think with, the ways of working, and methods and tools to make things. So I'm going to share a couple different projects. So this project is called Mecha Magnets. And as you can see, this is 3D printed stuff, physical input with embedded magnet. So I think it's an interesting idea to say, what if I only have 3D printer, a magnet? Can I make all the different gadgets? All right. As you can see here, you can design a different shape, embed it in, and you can have the text file feedback. Right, you can have switches, you can have push buttons, and have things that you rotate, right? Yeah. So can we reproduce everything so we don't have the order going off the shelf? Can you do things together at home? Make stuff. It's like fidgeting. Really cool to be playing with. So the magnet inside, so you have simple joystick, push, and because the magnet, they always go back to the locations. Yeah, right. There are many different things. Oh yes, this one is a push button. And I think, oh, I like this one, the slider. So you can see the different magnet places. So as you slide them through, it clicks through the place. Just like that. All right. So yes, you can keep designing. It's almost endless. Anything you can think about. You build a model, print it out, embed it in. Okay, so then the question is, what do you do, right? So basically you can arrange the magnet whether they're attracting or repelling, and depends on you arrange them in linear, polar, or angular. So you're looking at different interactions possibility. Okay, and then we can map like, okay, similar shape configuration, whether they have attracting in the center or repelling. So it depends on where you put the magnet. Similar shape could have different interaction and different haptic feedback. So instead of complicated glove, maybe it's important to have physical object that you get to play and get to feel it. All right. So one of the questions that what do you do with all the stuff? Well, one thing you could do is you could pretty much make any toys that could have simple interactions. So this is a frog. So you print it, it's snapped together. There's no glue. Well, there's hard glue for the magnet to be inside, but everything else is just snapped together when the magnet is in there. So it's repelling, so you push it down, it's always flip back. Right? So no matter how many times you push it, it's always flip back. So you could create object that started to have motions, movement, feedback. So this is one we put in a whole effect sensor. So once you have design, this is reminiscent of the whole okay. And then with the whole effect sensor, we can sense this is okay. All right, so we got a physical object, we have a simulation. Wow. Okay.
Ellen, can I ask a quick question?
Yeah.
Can you help people see how you go from the physical to the encoding for that?
Physical encoding. I can also share the paper that have the detail, right? So this is like, oh, we were just exploring. Let's do physical stuff. And then once we put Hall effect sensor, then we detect what signal you have. And so we write
The
a
Hall effect measures magnetic change, and you have a Hall effect sensor, like many keyboards do, that you just put there, and the magnetic going by, and it notices it, right?
Yes.
Okay,
That's correct. Yeah.
I just wanted people to note, to see that it's that those little shiny things on the insides of those parts you're putting together that are the magnets, right?
Yes. Yes, those are the magnet. And then when you put it together, I think with the controller, we put Hall effect sensor inside, and then we connect that. Yeah. So that's like the first game. And then we build another game. So this game is called Hot Swap. So same thing, you can see the gadget where they come from. They're doing 3D printing with magnet, but then we also have pogo pins. So now we are having different connections, trying to connect to the computer, looking at the input. So that went to the GDC, San Francisco, I think. Where was it? Game Development Conference or San Diego. Yeah. So that was they got the first prize for the alternative control, because they pretty much build their own control and their own game. So I'm going to share with you that Hot Swap game, all hands on deck. So everything here is built from scratch, including the plate. So those are 2 controllers, and we build things in Unity. This is a pirate ship on the ocean. So one ship, my input. There's 5, operate. Right, so you do the game with control, and the gadget is one is controlling the tail is controlling the speed, and then we have the M ability direction the boat is going, and then this is loading the cannon for the time. Fire.
Again, I want to make sure you say a little thing about those 6 contacts that are on inside there.
Yes, that's the pogo pin. Yes, that's the signal. But again, the more detail I can share all the papers, how things work. Yeah. And so this is the presentation. And because you only are collaborating. And then people come back and playing. They would change the strategy. So I went to the game, like 100 people coming, young people, partners, parents and kids. And so the idea is that you're swapping them. And so the idea is that you can start with things from what you print and to eventually do something. So I think one of the insights here is also, hey, if we can build something or besides 3D printing, there are lots of stuff around us, everyday object. Maybe they could also be interfaces. So that's showing you a couple more projects on interfaces. So this is one of project called Jump Station. It was from my class on music technology awareness. And you can see here the bucket, rain bucket, the PVC pipe, and then you can see the color LED light. So the color coded is for the harmony, so people play. This was those are other exhibit over there. For the makers make, so people come and do that. But meanwhile, you can also detect which one's getting hit. Are you making louder? You're making interesting stuff. So that's like, oh, found object could be interface. And here's a different project. It's about interface, but using paper as an interface. What if we can make kirigami and we can sense the paper as intention? So what we have here are the carbon-coated paper that some schools use it in the science experiment. But you can ask them, you can detect the motion, whether you're doing printing.
It's called an FSR, force sensing resistor.
So making our own force instead of just from the carbon-coated paper. Okay, you can do kirigami. So you can again have a simulation. So you know which one to press, you have a display. right? So meanwhile, right, so you can pretty much design different pieces through paper or cube design. And then the question is that what would you design? So one example is a lamp. So lampshade, you pulling one side, you could be dimming the light. Pulling the other side, be brightening. So I know we have the lamp that responds to the top or other things. So the idea will be object or everyday material, paper.
Ellen, there's a question for you.
Yes.
How do you get from idea to prototyping?
For idea prototype, once you have idea, you start prototype. And so this is what I show you already been done. They went through a couple different prototypes. Try this, say which one works. So thinking and making happen at the same time. Like what?
I think it's also you find and get familiar with and enjoy tools, and then you think of ways of using them also, right?
Yes. And then I think for the 3D printing part is also, hey, we have a 3D printer. What can we do? Can we print different shape? And then, but the shape doesn't have haptic, doesn't have interesting stuff. Can we make it more interesting? And who doesn't like magnet? Anyway, so some of the thing is just because things are wrong surrounding you, and we brainstorm or we make something. So Coleman made something. I say, that's good. Why don't you build me a dozen of different things? And so let's just keep doing it. And so the process of that, you figure out something works, something did not work. So this one is also interesting because we're still doing paper. And then we realize that there are markers that people, we can recognize, right? So this is setting up for the printed paper markers. What if that's a pop-up, right? So what you can destroy the marker together, cut them, and then you're making physical paper pop-up buttons. So this is just using simple computer vision, and we're setting up a table because we want to have the camera underneath. Normal phone camera will work. So CV computer vision, so you recognize the markers when you read it. There's a push back up. So now you can see different applications with paper. For example, this is data.
Company A sold 20 apples. Company C sold 30 apples. Company B sold 1.3 times the amount of apples as Company C.
Right, so you can do visualization.
Company X started the fiscal year at 22 points. Company X decreased by 36% in the second quarter.
And this one is new. So it's like stuck at home. What if teacher is sending a pop-up card? Camera, plate, Siri, everything sync with scratch. Marker is changing, right? Like, oh, so there could be physical interactions that you're doing and doing prototyping. Oh, I love this one. You can have your own MIDI controller, right? Different sound, you can change the volume or rhythm, speed, right? And computer vision is showing you. That's really helpful. Right. So this is the idea, like standing on paper, but just simple computer vision with AR marker. You can do stuff. So we got continuing on the paper interaction. So for example, you can see, hey, the buttons, or you can have accordion. So you destroy or make it invisible. And we also using that to do like physicalization or making arcade games. So let me show you the data visualization.
To help foster children's data literacy, we designed a series of DIY paper charts using AR markers and everyday materials. We focus on how informal learning through crafting and play can help children map, read, and update data to the visualizations while drawing meaningful connections from everyday examples.
This was like an early prototype. And then you saw the markers. And so this idea is just to do tiny arcade. You don't get to do 3D printing at home, but you have lots of cardboard and you can draw, print markers. So yeah, similar to Labo, having a pattern, cutting it off. Have them together. Well, this is basically setting up the arcade for machine. Put it together and you can do your own controller. Right, so cardboard you can draw and using smartphone as a screen, so you can program your game over there. But using a camera, it's looking underneath the controller as a mirror, seeing the marker. So moving around, both the screen and the camera. Also. Yeah, that's a big one. Yeah. Want it? Okay. Like, shape. That's fun. Next, so I mean, we started and more students are interested in what kind of thing can we play with paper. So this is the escaping pickup box. What she put in is like vibration with the sensor proximity. So as you trying to grab it, it's moving away, it's shifting the weight. So it's just playful way of thinking about how many different interaction you can do, right? So not everything have to be plastic or existing. You could be making your paper robot, you can making your pop-up cars, turn on the lights, whole bunch of stuff. Okay, and I want to touch on a couple different projects now on paper. This one's on augmented reality. So one example here is making a programming language pop in, pop out on the virtual reality. So the idea is that quite often you are in the world, you want to change something, you ended up coming out and try to program. What if you can make that object in the programming right in the virtual environment? So you're not trying to take out your headset, come in and out, because it's impossible to be typing in the virtual environment, just grab object. And then here's a project that we did for the EPRI, Electrical Power Research Institute.
This is ARMAS, Augmented Reality Maintenance and Safety. Site operators can use ARMAS to streamline maintenance work and to get critical safety information.
Marker.
The site walk view gives operators an overview of conditions inside the enclosures as they walk by. It also provides directions through the energy storage facility. The X-ray view lets operators see what's happening inside an enclosure before they open it up and go inside. In this enclosure, everything is fine. But in the next enclosure, one of the units is overheating. Operators can zoom in on problematic units to get more detailed data. This enables operators to understand the problem immediately without getting too close to the enclosure, so they can move to safety and call a subject matter expert for help.
Yeah, so what happened is a couple years ago, one of the solar power storage unit was on fire, and the first responder showed up and they open the container and they got blown away. And if they have an X-ray view, maybe they will see through and they won't, they know, let it burn off. There's oxygen about to run off. So we have worked on a couple of different augmented or mixed reality project because people say, hey, you guys are doing technology, can you help us? So here's a different one. This one was sponsored by Ericsson. They were interested in like their network communication and delay. And the first project we did was remote technician plus remote expert communication. And then the second one, we started to do drum. So I'm a drummer, people drum. It's frustrating trying to drum over Zoom. The question is like, can you make the experience more interesting by giving your avatar?
Use augmented reality glasses to place personalized musician avatars and jam with them. No one to jam with? Create a new avatar and record a looping beat for them to play. Once a new avatar is there, they will play the beats along with you. Now you can jam with different versions of yourself and create compositions on the fly. But hey, wouldn't it be cooler if you could also jam with your friends around the country and around the world? Just like the avatars you make for yourself, your friends appear in your AR headset as avatar musicians. You can now jam with your friends in spatial surround sound. Not sure how to play the drum beat? Color-coordinated splashes show you what has just been played and can help you follow along to the beat. The remote audio still suffers from network delays, but the visual effects work to counteract latency, enabling you to have an AR drum circle in your home.
Ellen, are those simulated glasses or are they real AR glasses she's wearing?
That's Nreal. So those are
Nreal.
real glasses, Nreal, yeah. We ordered from China. It took 6 months to arrive. Anyway, they're pretty lightweight. They really look like sunglasses, so that's pretty cool. I got 2 sets with the developed kit. So we have the real, and it also have speaker as well, microphone speaker. We're doing more, and we're adding like haptic feedback because like there's network delay, and we're trying to figure out what kind of experience you can enhance it, even though you know there may be delay, you can still enjoy it and play. So we're trying to figure out between the sound and the visual and the haptic, and we are playing with different things. Like we also like doing apnea, trying to see when you're jamming, are you in the flow? Are you competing or are you relating to each other? So that's just another thing we're trying to figure out as well. And this is the newest things that the students were playing. And the idea is that what if that like hologram, I know you can see the reflection, and we have different fidelity of the drama as well, right? And you can have the avatar looks like a skeleton or people. And what if most of the AR glasses, the field of view is not that wide, right? So what if you have immersive peripheral view, and we can do experiment to see like how much can you pay attention to, can you track them, and compare that with the AR glasses to immersive display. Anyway, so we're just playing with different things. Oh, here's another data visualization. This will be presented at Keio. So the idea here is doing, hold on. Yeah, so the idea is that when do you do digital visualization, when do you ethical? And it makes sense. So we review a bunch of paper. It started from 500 to 300 to 100 to down to 47. Compare what kind of thing they do. And you can look at context or interactions or structure, how the object was done. And we look at different projects. Some of them are direct manipulation, some of them may be inferring on the physicalization. Anyway, so some of the things we do is fun. So this is like, I probably did not list everybody, but a lot of people help in the project. It's a lot of fun. Let me show you 2 more projects. This is more human robot interaction or robots. So the idea here is you can see that the robot, little robot and little rack that you can move up and down. So you may be in the virtual environment and you don't have to have the whole set, but the set will be moving depending on where you are regionally. Right? The table and other things. The room could be shifting depends on where you are. Right, of course, this is totally VR, and if you do have AR, so different experience. And here's another one with little robots. So this is lots and lots of small robots, swarm robot. They are called a shape butt because they have cute little shape and they can change shape as well. So yes, in the region one, and so the idea is what if all your objects are little robots. And so this is like you move them and this is like spacing paper, so sending different axes. Different transformation, right? The little robot moving, extending x1 or vertical, extending with the whole here. So there could be different applications. For example, for data visualization, this is a map, and the little robot could be showing the demographics of each state, and so what to do, based on the and last for this, right? Okay. The little robot look at for you. Touch you. Don't touch it right now. It's hot.
Starting it.
Right. So 1 minute later, it's cooling down. It won't burn your tongue. You can drink so then lower down, move away. Right. So what if all the things you're interacting knows your intention, what you listen, what they're informing you, helping you. So I like this one. Right. So you may be doing that and trying to manipulate the model, and the little robot is showing you like, oh, how much of real estate? What if you can there? Then you can click it. I don't really buy this one, like for the cleaning robot. But yeah, I guess those are right. Rectangle. How about make it bigger? Right, so that it's in the or show me triangle. So okay, so rectangle. You out. Right. So there are multiple ways to connect. So on that note, I think the student put this together and like showing how happy we are. And of course, hanging out. ACME Lab. So I think I may be going too fast, but it's okay. Fun with creative technology and design. And I think if you come to Atlas in one of those days, I think April 28th, we do have an expo. So people would demonstrating different projects and a couple of things that we think we having fun, but we also like creating magic in Atlas Institute. And there are two things, of course, we have to quote Alan Kay about the best way to predict the future is to invent it. So we like to invent stuff. And the magic part comes from Arthur Clarke, right? He helped the screen script for 2001. And also he did the satellite communication. So the idea is that any sufficiently advanced technology is indistinguishable from magic, right? What if we can make technology like, oh, it feels like magic? Where's the interactions? Where is the interface? Where's the user experience? All part of that. And so on that, welcome to come. I will show you around and I will stop sharing. And so I can see everybody. Where's
good. Great, fantastic. You should see the questions. I mean, the comments. People are having a delightful time listening. They continually ask questions about sensors and actuators. And I think what I always, when I teach these courses, I love to teach people that, you know, sensors can be resistive, they can be inductive, they can be magnetic, they can be optical, they can be and they can be and you can use, you know, anything to activate those electrical sensors. Actuators can be electromagnetic, they can be electrostatic, they can be piezoelectric. So, you know, they can be pneumatic, they can be with air, and they can be hydraulic with fluids. So these are kind of your building blocks when you're building things. And then with physical things, you know, you say, well, I've got my shop. I can make my things with my 3D printer. I can make things with my laser cutter. I can make things with my water jet. I can make things by sanding and manipulating in craftsman style things. And you know, I can mold things. And so what we want to do in our life is, for whatever we're learning to do, we build a quiver. That's all of the things that you can, the quiver of tools, and we use the tools that we can have. And so one of the things Ellen's doing, she's using a lot of resistive technology. She's using cameras. She's using magnetic, and so that's kind of, you know, I noticed that was one of the things that people are asking. Sorry that I go on about this. I want to see. Oh yeah, some people are saying maybe you should be showing these things in the Exploratorium. Have you ever talked to them?
Yeah, good point. I've been to Exploratorium many years ago for fun, just exploring. But yeah, that's
and how much of the teaching, you know, do you talk about materials in your courses? What do you know, tell a little bit about your curriculum, maybe?
Well, we have multiple courses and projects and stuff. Yes, we have people talking about code, writing code, talking about object interactions, talking about material. We have something we call creative technology. And so Mark is teaching a wearable class. And so different semester, different people offering different approach of how we look at the future interaction. And so, yeah, all the courses, we went through different module, and so depends on people's idea and experience, and we can say, okay, let's just do everything with paper. Let's just do everything with different sensor. And that was the arbitrary decision. We say, okay, if we don't want to write too much code, then I just want to figure out people can use the marker to recognize it, and you can do stuff. I mean, I think we are having a lot of fun to see how many ways you can destroy the marker, like scratch or make it invisible, or having things that maybe like a catapult, you move and flap. So it's just a fun thing to think about. Oh, sure. What other thing would
so
do?
Like the paper thing you're showing us, that those cuts were made with the laser cutter?
Yes, but yeah, you can also use a X-Acto knife as well.
Of course. Yes. So Sharash wanted to ask a question. I've unmuted him. Please, please, maybe even show your face as you're asking, if you can, Sharash.
Yeah, sorry, it's my camera is not ready, but yeah, I'm excited to see so much work today. It was amazing, very inspirational. Ellen, 2 questions. One,
yes.
What technology you used to show the hologram? Like there was hologram floating around. And second, question is, how do you, like some of these interfaces, it would be cool if a lot more people use them than just mouse and keyboard. So what are some ways to take these to the broad masses and have them use some interface like this for their computers or games?
Yeah. So there are two questions. So the first one about the hologram, I know this totally illusion. You can actually see the screen right there, and that was just a plexiglass or reflecting. But because we can see through the background, it really gives you the illusion that it's right there. And so being able to see through that, and we're thinking about, we just do a whole bunch of those plexiglass, because when we do remote classes, we have to put a plexiglass in between the teacher and the students if they don't wearing that. So we have a whole bunch of those, and we say, okay, what else can we do? We adjust it to the angle. And so then if you are drumming with them, you sit through, you don't actually see the screen, because like, this is my angle. And then literally you feel like they are floating. So we don't have real hologram, but it was enough of illusion that people enjoy going there to drum and play. So the telepresence was created by reflection. So there's no real AR there or real hologram. The next question about different interface. I think that's part of the thing we're interested, for example, for game, we're interested in alternative control more than everything is mouse and keyboard, or we just constrained to PlayStation or anything like existing. So what if you can come up with a game and then figure out what the interaction you want? And so hot swap come from that. Basically, what if I have my pirate game and I don't want to use the PlayStation or any other way to control, or mouse and keyboard? What would you control? And so the student was thinking about, oh, if we can raise the sale, we can do other things. So then they can design all your gadget. Yes, we would love to be able to expose that for more people to think about their alternative control more than just mouse and keyboard or pen. And thank you for the exploratory suggestion. And I think that's why we do Expo. We want to see people come in and do stuff. So some of the students and Mark and I would both have a couple different startup companies, some successful, some exist, and some just not there because the students say, I want to be hired by somebody. So we may start with a startup company, but didn't continue. So yeah, in our atlas, we have people doing stuff and also thinking about how that can be commercialized, but I don't teach that part. We just see the opportunity, say, oh, there's people interested, let's do that. I have another startup company just started like just before COVID, and just like, okay, there's no way you can do any user testing this past 2 years. So that's pretty frustrating.
I mean, we do what we can to make it mass marketed. All of you are responsible now for getting Ellen's ideas out into the world and making them matter.
Nice.
Yeah, I think that's a really good synopsis. I think one of the things that people have a hardest time with is this idea that visualizing these opportunities. And for you and me, what I always want is I want somebody to come to me with a question. I want to see a tool and think about how to use it. I want to think about some way of making something I see easier to use or better to use, or something that people would play with. So, you know, the way you ask questions is the way we create. Ellen, you want to add to that, I'm sure. What do you want to say?
Right. So I think some of the things we said is figure out what's the want, right? So there's something like you realize that you need that. You may need something, it's not working, or something you observe what's happening. So I'm not doing the traditional, like, do user study, figure out specification before you build. I actually encourage students start thinking about, this is something I want, it's not there, or this is something, it's already there, but it's not doing what I wanted. Can I take it apart? Can I add things to it? And so it's like, that's something I want for myself. And so instead of figuring out specification first, I let them drive with their passions, their curiosity. Like, oh, so like early on, one of the students said, I want to learn to play piano, I have no time to practice. And we all laughed, so why don't you have possessed hands? And that's exactly what he built. He built the glove that will vibrate and tapping, all right? Another person said, well, I want people to jam, but they're afraid. So you look at the jam station, we say, well, what if they're color-coded? So you see another person's always hitting red, yellow, blue, blue, you can do the same thing, you'll be in harmony. So some of the project idea come out because one person say, oh, what if I do that? And then other people start jumping in and say, and
yeah. So another thing I think maybe you do is sometimes I build things to think about things.
Yes.
So yeah. So a lot of those things, you kind of had an idea and then you kind of expand on it and try new examples of that. so many buttons, so many switches, so many levers, so many sliders, right?
Yes, right. And so basically, I mean, Columbia arbitrary because I bought like 2 3D printer and I say, okay, let's print. What can we do? And say, what if I could do a switch? And once you do a switch, originally he want to put the Mac, then put the copper, do other thing, and people not interested in that. But everybody was interested in clicking, pushing it. I say, let's build a couple more gadgets. So that's how we started mapping it. And so other people suggest, and then Peter always say, oh, we can build a game. So they start being the Pong game and said, Pong is not interesting. Let's do a pirate game. And so it's one lead to another. So having the environment that people are brainstorming and helping each other is pretty fun. I mean, my students come from different backgrounds, from computer science, electrical engineering, industrial design, music, toy design, philosophy. Yeah. And so when you have a group of people say, oh, let's figure out what we can do. And as Ted said, I like to have fun. So my students, we are having fun just being goofy and think about something else to do.
But I think in a more serious tone, one of the last things to go for an Alzheimer's victim is their ability to use the physical world to remind them to think. And if you give them a towel, they will fold it perfectly. But in fact, the physical world is a memory aid for all of us. And it's also a perceptual aid. So what's in front of you, you think about. And I think that's part of what's going on here.
Right, and we talk about embedded cognitions, right? So we're talking about a cockpit, the pilot actually remember where things are, so part of the body movement and how they control. And so I think we probably all have our own arrangement where things are and your motions. And so doing something tangible more than just on the screen, I think is really important. I see there's a question about online MOOC. We don't have it yet, but we're thinking about offering that. But some of the things is about physical doing. And so I think it's more fun being in the same place. So we suffer a little bit for the past 2 years when we're remote, we've been in person, that's good. But the tiny arcade also happened during the pandemic time because not everybody is 3D printed at home, but everybody whole bunch of Amazon boxes at home. So we say, okay, can we get rid of those boxes? Can we make them do something useful? And so we're building the arcade game or other stuff like arbitrary limitations. Say, I don't want to use fancy software, hardware. Can we just build stuff with found object? Yeah.
Well, what do you think about visiting the exploratorium that keeps coming up, Joyce? By the way, I know a friend, Spielman, anyway, Spieltech, that did this. It's a pretty exciting thing. People like you or me might have a lot of fun. They have a beautiful shop, and then they have this possibility of making a lot of people get the value.
Like to do that.
Yeah, it'd be fun to have you around. You can stay with me.
Okay. I just have to figure out what I'm doing right now. Yeah.
I think you're pretty busy.
Oh, I'm having fun. I'm going to the Creativity and Cognition Conference, and so I'm taking students over to, it's going to be in Venice, Italy in June. So that's fun too. Yes. Yeah, so the tiny K paper got in there as well. So some of the project all have paper documenting all the things. I think I'm easy to find on the web. Yes. Okay. I'm sort of air there. Yes, go. Cool.
Oh.
Nice.
Oh, that's a very good question.
Good books.
What are the good books to learn about tangible and interactive?
Well, none about it. We'll probably come up with a project.
The Maker, I think all of the Maker magazines, that was about 5-10 years, and the Maker book are good places, wouldn't you say, Ellen?
Yeah, that'll be good. And I think come up with the project and then figure out what's needed. And there are lots of online video, people sharing how they make something.
Okay.
And when there's a need, you will find it. Yeah.
And collaborations are opportunities. That's what you hear from Ellen. So maybe, maybe there's an artist in residence in Colorado. I don't know, in Atlas, if you guys ever have people come.
Do. I think we do have artists in residence. I think the Laura Devendor's lab, Unstable Design Lab. So she has a jacquard machine. So that's a giant weaving machine. And I think they're doing like weaving artists in residence. And then I think Mike is starting. I'm not sure there is a resident there, but we have a black box theater as well. So we also have program for artists in residence. So people can come and say, I want to use a black box. So for 2 weeks to do a performance, we have motion capture in the black box.
The what box? Say that again.
Black box.
Black box. How big is it?
I don't know the exact dimension, but you can hang a truck from the extension grid will still stay. So it's pretty big. It's like a experimental drama club.
Like 20 by 20, as big as a room.
Oh, bigger than the room. Bigger than the room. So this is, sorry, this is what I am. My background is one of the performance we did. So we actually hang different curtain. We can change the lighting. And this is just like a quarter of the space. And we are doing like puzzle, people have pieces, they fit into places, and we have pad. We design a pad as people stepping on and the video start changing. And we build a wearable as the dancer, when doing performance, depends on which way they move, they change the lighting. But then of course, we quickly realized that they sweat as they dance. So some of the lighting color changes started to trigger, even though they're not in the motion. So it was pretty amusing. This is the background behind me. I mean, it's just part of, that's probably like 1/6 of the space. It's huge. You can park a whole truck inside. And we also have trapeze performance. We can hang people. We have multiple screens. So black box theater, B2.
Cool.
Yes.
Yeah, it's kind of neat. I think at the Media Lab, we had something like that, but it didn't always get used probably as much as it could. And I think those kind of performance spaces are really exciting when the technology can be integrated.
Yeah, so there are lots of stuff over. If you showed up, yes, we do have artists in residence and stuff. And then this is our website. I think we have a performance just this past. We can, oh yeah, anyway.
Well, this is a lot and it's all great. And I think a lot of people are gonna enjoy seeing this video later as well. And Ellen, it's always delightful to see you. I wish I had more of you in my life. We always enjoy each other when we get together. I hope I haven't been presumptuous in my speaking a little bit about some of the techniques and technologies as I.
Oh, that was wonderful. Thank you.
And I hope that people will tell their friends to come and watch the video on BayCHI to see Ellen. And Ellen, you will be on YouTube and on BayCHI.org as a video you can point people to.
Okay.
It will start off with just raw video for the first month or two, then we will edit it and make it nicer, okay?
Yes.
And so I really am so appreciative of you taking this time. You offered, and I was just really happy to find a moment when we could have you speak. Quite frankly, I've been around you so many times, and yet there were things that were brand new for me here. And you know, and that's great too. Even though I've seen your little expanding carts in person, and they are even, by the way, the things that she sewed in the videos, they're as exciting or more exciting in person. So they're not just fake, they're real. So with that, I think that we can bring BayCHI program to a close for the evening and let you get on with your evening too, Yi-Luen Do. And we love all of those backgrounds you're showing there. I should let you be, I should stop sharing so you can be sharing if you want to be. But anyway, thank you everybody. And with that, we'll see you next month, okay?
Bye. Thank you for having me.
Thank you so much for coming.
Happy birthday, Ted.
Thank you. Okay, bye-bye.
Bye.